In this video, I will talk about powers of a matrix, and especially I will talk about non-negative powers. But in the next video, I will talk about a negative power. Here we have A, which is 2 by 2 matrix. Here, 2 by 2 matrix, which is 1, 1, 0, 1. Here, the elements. Find A bar 0, A bar 2, A bar 3, and guess a formula for A bar n, where n is any positive integer. Here we have this one, we want to find it, then after these thing, because it's like a pattern, then from that we conclude what is A bar n. Here, this one, it's equal to A multiplied by A multiplied by A until here A, and these are n copies. So we can define this. The power n of a matrix for non-negative integer is defined as the matrix product of n copies of A. And you can see here A bar 0. What is bar 0? A bar 0, a matrix to the 0th power, is defined to be identity matrix of the same size. So here A bar 0, it's equal to identity, which is size 2 by 2, which is similar to a number with power 0, which is 1. For example, if you have 5 power 0, it's equal to 1. Here the same thing, but in a matrix is different because the answer will be identity matrix. Let's erase this one here. So most of the rules of rising matrices to a power are obvious. I will write them up in details to make sure you are fully understand the power of non-negative. So let's go up and write some rules here. I will write here properties of rising matrices to a power. So here I wrote properties of rising matrices to a power. So it's gonna be so simple and easy if you know the rules or the law of exponents. So let A and B be n by n matrices, so A matrix and B a matrix, and let P and Q be non-negative integer. And to illustrate what is non-negative integer, it's mean from 0, 1, 2, and until infinity. So start from 0, non-negative, but the natural number starts from 1. So that's the difference between non-negative and natural number. Here I will write first property. So here we have the first property, A bar 0, it's equal to identity, and you can see here n, which is n by n matrix. Let's write what this one. So I represent identity matrix. Here A bar 2, it's equal to A multiplied by A, and you have to remember here it's like here 1 and here 1. It's like as we said before, for example 6, which means 6 power 1. The same thing here in matrices. We don't need to put 1 because it's obvious it's power 1. A bar 3 equal A bar 1 multiplied by A bar 2. So if you add these exponent, you will get 3. So 1 plus 2 equal 3. As we said before, the power n of a matrix A for non-negative integer is defined as the matrix product of n copies of A. So here the copies, here we have 3, so we have multiplied 3 times. So A multiplied by A bar 2, and A bar 2 is equal to A bar 1 here, A bar 1. So A bar 3, it has 3 copies. And the same thing here, a power 4 equal a power 1 multiplied by a power 3, and so on. So let's illustrate what this one mean. So a power 3 is the same as a power 1 multiplied by a power 2, which is the same as a power 2 multiplied by a power 1, which is a multiplied by a multiplied by a. And you can see here it's commutative product. So a multiplied by a power 2 is the same as a power 2 multiplied by a power 1, and so on. And example for this one here, let's write example for this one. So for example, let a equal, for example, 1, 2, minus 5, 3. Then a0, since this one here, this matrix is 2 by 2 matrix, so we have to write it like this. Then I, it should be identity the same size of this matrix, which is 2. If 3 by 3, then it's gonna be here 3, equal to 1, 0, 0, 1. So that's it for the first property. Let's write the second property here. So here we have the second property, a bar p multiplied by a bar q, where p and q are non-negative integer. Then the answer will be a bar p plus q. So for example, if you have here 3 and you have here 5, the answer is gonna be a bar 8, which is the same as this property. Let's illustrate this one here more. Similar to 3 bar 2 multiplied by 3 bar 4. It's equal to 3 bar 6. So you add the exponent here, which is the same as numbers here. But here we have matrix here, which is the same rules as the numbers. Now let's write the third property. So here we have the third property, a bar b, the whole thing bar q, which is equal to a bar p multiplied by q. So for example, if you have here 3 and here 2, the answer here is gonna be 6, which is similar to multiply the numbers. For example, here 2 bar 4, the whole thing bar 3 is equal to 2 bar 12. So the same as numbers. So if you have exponent here 4 for 2 and the whole thing exponent of 3, then the answer will be 3 multiplied by 4 here, it's gonna be here 12, which is similar to matrices. So a bar p, the whole thing bar q, give us a bar p multiplied by q. So it's very obvious. Now let's write the fourth property. So here, as we said here, identity matrix which represent like this, in here. So if we have I and the whole thing power p, so the exponent here for identity matrix p, it's equal to itself. So the power it's not affect with identity matrix. For example, let I3, which is like this I3, 1 0 0 0 1 0 0 0 1, then I3 bar 10 is equal to the same thing here, matrix. So we took power 10 here for this matrix, which is similar to identity matrix, which is this one. So the exponent in identity matrix, it's not affect the identity matrix. Now let's write the fifth property. The fifth property here, AB, the whole thing power 2 equal AB multiplied by AB. B, which is n by n matrices. So as we define it here, A and B, n by n matrices. So you can distribute the exponent here. So you can't write A bar 2 multiplied by B bar 2. Sometimes it's work, but in general, this is like this. I will explain this in the notes after this one, but let's illustrate this one here more. So you can write this product like this, A, then you can product BA, then product B. So you can product only these two, BA, then you have to product A from the left of BA, then after that you have to product A BA multiplied by B. But in general, we like in linear algebra to solve it like this, so only multiply this one 2 times, which is 2 copy of this one, multiplying together. The same thing here, we haven't distributed like before, like a square plus 2ab plus b square. No, in general, it looks like this. And if you want to simplify it more, you can simplify it like this. A multiplied by a, which is a square. A multiplied by b, you have to make sure you put the order. So a multiplied by b. So we have to write it a multiplied by b. Then b multiplied by a, b multiplied by a, then b multiplied by b, which is b squared. So we can't simplify these two together because we know ab it's not equal to ba in general, but sometimes it's work, but in general you have to write it like this. Unless ab equal to ba, we know we can write it to ab. I will put it in the notes below. Here we have ab bar 3. We have 3 copies of ab. So you only need to find ab, then multiply by itself 3 times. So let's write here a note below of this one. Let A equal this matrix 1, negative 2, 3, 4. Then if we want to square this A, it's gonna be like this, A square equal A multiplied by A, which is similar to here, A square, which is A multiplied by A, equal. So I will copy this one 2 times here, which is equal. So this row multiplied by this column, so 1 multiplied by 1, which is 1, negative 2 multiplied by 3, which is negative 6. The second component here, this row multiplied by this column, so 1 multiplied by negative 2, which is negative 2, negative 2 multiplied by 4, which is negative 8. Now this row by this column, 3 multiplied by 1, which is 3, 4 multiplied by 3, which is 12. Now this row by this column, 3 multiplied by -2, which is -6, 4 multiplied by 4, which is 16. So the answer for this first element here, 1 minus 6, which is -5. -2 minus 8, which is -10. 3 plus 12, which is 15. -6 plus 16, which is 10. So our answer is this one, which is correct here. But you can't write it like this. A square equal 1 power 2, -2 power 2, 3 power 2, 4 power 2. So this is wrong here. So you can't write it like this. But sometime if you make the square inside, it's equal to a square if you write it like this. But in general, you have to write a multiplied by a. Then you have to find it like this. If you put square here, it's not correct. So it's not multiply matrix by matrix in linear algebra. Second note, a plus b square, which is this one here, it's not equal to a square plus 2ab plus b square. But sometimes a square plus ab, which is this one, plus ba plus b square equal to a square plus 2ab plus b square. And this is happening if a b equal b a. So if a b equal b a, so if these are equal, then you can write it like this. So you can write it a squared plus 2ab plus b squared. But in general, you have to write it like this. So that's it here for the rules. So now let's solve the problem. Now let's solve the first question here. 1. A bar 0 is equal to, as we said before, it's equal to identity with here 2, which is 2 by 2 identity matrix. So here it's equal to 1 0 0 1. A bar 1, we don't need to write it, but I write it here to illustrate for you. So A1, which is this one, 1 1 0 1. A bar 2, which is a multiplied by a. Of course, here 1, equal. I will copy this one 2 times here. Now let's multiply these two matrices here. So this row by this column equal 1 multiplied by 1, which is 1, plus 1 multiplied by 0, which is 0. Now the first row by the second column. So 1 multiplied by 1, which is 1, plus 1 multiplied by 1, which is 1. Now the second row by first column. So 0 multiplied by 1, which is 0. 1 multiplied by 0, which is 0. Now the second row by the second column. 0 multiplied by 1, which is 0. 1 multiplied by 1, which is 1, plus 1. So the answer here is gonna be 1 plus 0, which is 1. 1 plus 1, which is 2. 0 plus 0, which is 0. 0 plus 1, which is 1. So now we have found a power 2, which is this one. Now let's write a power 3, which is equal to a multiplied by a power 2, as we explained this in the rules. Equal. So I will copy this one first, then copy this one, the second matrix here. Now I will multiply it faster than here. So let's write it here. So this row by this column. So it's gonna be 1 multiplied by 1, which is 1, plus 1 multiplied by 0, which is 0. So it's gonna be here the answer 1. Now here 1 multiplied by 2, which is 2, then plus 1 multiplied by 1, which is 1. So it's gonna be the answer 3. Now the second row by the first column. So 0 multiplied by 1, which is 0, plus 1 multiplied by 0, which is 0. So it's gonna be here the answer 0. Then second row by second column. So 0 multiplied by 2, which is 0, plus 1 multiplied by 1, which is 1. So the answer is gonna be here 1. So you can find the pattern from here. So here 1 1 0 1, then here 1 2 0 1, which is here increasing. This one increased to 2, then 2 increased to 3, and you find the pattern. But now let's write it more. So let's find A4 to make sure that we are correct. So here we have, now let's write A, which is this one. Then let's write A3, which is this one. So this row by this column. So 1 multiplied by 1 plus 1 multiplied by 0. So 1 multiplied by 1, which is 1, plus 1 multiplied by 0, which is 0. Then the answer is going to be 1. Now this row by this column. So 1 multiplied by 3, which is 3, plus 1 multiplied by 1, which is 1. So 3 plus 1, which is 4. Second row by first column. So 0 multiplied by 1, which is 0, plus 1 multiplied by 0, which is 0. So 0 plus 0 is going to be 0. Now second row by second column. So 0 multiplied by 3, which is 0, plus 1 multiplied by 1, which is 1. So 0 plus 1, which is 1. Let's go down. So we found this as a power n, it's gonna be equal to like this 1, and since here 4 and here 4, 3 here 3, 2 here 2, and the same thing here 1, it's equal to 1, 0, and here 0. So we can find a power n here. This element it's gonna be here n, then here 0, then here 1, where n is any positive integer. And of course, you can write it for any non-negative integer since it's valid for a bar 0, so you can write it for any non-negative integer. So we have solved the first question here. So let's solve the second one, 2. So they want us to find a 2025, which is very easy here to find it because we have already the formula. So since here the exponent here 2025, so you have to write here 2025. And here this element is gonna be the same, so 1 0 1. So that's it, we have solved the problem. In the next video we are going to find for negative power for the same problem, but for the negative power, for example negative 2025, in the next video. And of course, this way to solve this here, this guessing for n power for a, you can find it in another way. For example, diagonalize the matrix A. I will talk about this, how to diagonalize a matrix to compute powers of a matrix. To diagonalize a matrix, you have to know what is the eigenvalue and eigenvector. I will illustrate this later at some time in the future. Thank you for watching.